Gas laws introduction. So, when studying the gas laws, we will investigate how gases behave when they are under pressure in a closed system. Now, what is a closed system? It's one with a constant amount of moles of a substance. Therefore, it is not open to the atmosphere, which means that within some kind of encasement, some kind of closing, the gas pretty much will not have any additional molecules added to it from its outer environment. Other key concepts to keep in mind throughout the following videos, as we're going to see, is that the average pressure of the atmosphere at sea level is taken at what we call a standard pressure, which happens to be 760 millimeters of mercury, which is equivalent to 760 torr, which is equivalent to 1 atmospheres, which is equivalent to 101.3 kilopascals. So these are for the more common units for pressure that we will see throughout the gas laws unit. So you can use the following when converting units of pressure from millimeters of mercury to torr to atmospheres or to kilopascals. Freezing point of water is at 0 degrees Celsius or 273 Kelvin, which is defined as the standard temperature. 273 Kelvin is a new set of units that we will be looking at for temperature as well. Now, combine both of these conditions, your pressure from the previous slide and the temperature from this slide, and you have something that's referred to as the standard temperature and pressure, otherwise known as STP. The normal conditions under which we live are referred to as the standard ambient temperature and pressure, aka SATP, which is defined as 25 degrees Celsius or 100 kilopascals. Now, temperature units in absolute zero. 0 degrees Celsius or 0 degrees Fahrenheit are not considered absolute zeros. In fact, temperatures well below these numbers can actually be achieved. So absolute zero is defined as precisely 0 Kelvin on the Kelvin scale, which is the thermodynamic or the absolute temperature scale. And if you look at it in terms of the degrees Celsius scale, it's at negative 273.15 degrees Celsius. So if we look at the following graph, what we have here on the y-axis, we have the volume in liters. On the x-axis, we have the temperature in Kelvin. And so because we have an absolute zero being at 0, pretty much at 0 Kelvin and at 0 volume, and as we're going to notice when we study the Charles law, we're going to see that pretty much as we increase in temperature, we are going to have an increase in the volume. And so if we were able to lower the temperature all the way to 0 Kelvin, then the volume of the gas would be at 0 liters. Temperature units. Convert degrees Celsius to Kelvin. We're gonna take pretty much the temperature in degrees Celsius, and we are going to add it to the number 273. If we're going to convert Kelvin to degrees Celsius, depending on what your question asks, you're going to take that Kelvin measurement and you're going to subtract the number 273 from its answer. So let's look at a couple of examples. We're going to convert 21 degrees Celsius to Kelvin. So 21 degrees Celsius, we're going to add 273 to it, and our temperature in Kelvin is 294 Kelvin. Now, if the question allowed us to calculate our Kelvin and they had asked us to convert it to degrees Celsius, well, we'll take the Kelvin measurement. We're going to subtract it by 273 to give us a temperature in degrees Celsius, which is 14 degrees Celsius.